Okay, student. So today we are going to start a new topic of chapter 5. Okay. So our topic is bar magnet as an equivalent solenoid. Okay. So our chapter number 5. Our topic is bar magnet. What? Bar magnet. Bar magnet is an equivalent solenoid. Yes. So today our topic is bar magnet as an equivalent solenoid. Okay. So in the previous class, we know that a coil, when current is passes through it, it behaves like a magnetic dipole moment. Okay, when consider a coil, when current passes through it, then it behaves like a magnetic magnetic dipole moment. Okay, and also we know that in the previous class we discussed about the dipole moment, magnetic moment. Okay, in the previous class we know that the magnetic moment denoted by m is equal to what? This n I a. मैग्नेटिक मोमेंट का जो फॉर्मूला था हमको क्या था? दिस एम आई ए. Here n denote the number of turns in the coil. Okay, here n denote number of turns in the coil, I denote the current through the coil, and A, capital A, denote the area of the coil. Okay, and so from this now we are going to start the topic, what is a bar magnet as an equivalent solenoid. Okay, look at this. जो ये bar magnet है, we know that the bar magnet, a magnet has two pole, north pole and south pole. When the bar magnet is placed in the uniform magnetic field. Okay. First, let us consider a circular solenoid. First, let us assume this. Let us consider a circular solenoid. Okay. The circular solenoid is divided equally two parts. Okay. When it is divided equally two parts, then it is the center point. Okay. When it is the center point, then it becomes radius. We assume the radius is A. Okay. We assume the radius is A. So let P be any point. Okay. So P be any point at a distance r from the center. So we have to find out the magnetic field. We have to find out the magnetic field at the point P. Okay. Now we are going to start clearly. So now I am going to let us consider a solenoid first. Starting, the topic is start. Okay, some problem arise. consider this is a what? This is the circular solenoid. Let us consider a circular solenoid. This solenoid is divided equally into two parts. Okay. When it is divided equally into two parts, then consider this point O is the center. O is the center. So when it is the center, so this is become radius. This is become radius. So radius is divided by r. No? This is r is equal to this is a. So then we assume that radius is r. Okay. So now let P be any point. P be any point at a distance r. At a distance r from O. Now let P be any point at a distance r from O. We have to find out the magnetic field at the point P. Okay? We have to find out the magnetic field at the point P. Now, let us assume a small segment. Now let us assume a small segment. This is the small segment, okay? A small segment at a distance x from this. Now let us assume a small segment x at a distance x. Okay. Now from here to here the distance is x. Therefore, from this point to the point P, the distance becomes what? This is r minus x. Okay. From here to this point. So we have to find out the magnetic field at the point P from where? From here to here. So we have to find out the magnetic field at the point from here to here with a distance what? R minus x. So if anyone asks you that what is the number of turns in this coil, in this circular part? What is the number of turns? The area of this part is, let us assume dx. This small segment area is dx. Now, what are the number of turns? What are the number of turns in this small segment dx? Then we can say that the number of turns is what? The number of turns is n dx. Okay? The number of turns for the small segment is n dx. And we assume the current passes through the solenoid. The current passes through the solenoid is I. Okay. Okay. Now, let us consider a bar magnet. It is when it is placed at a uniform magnetic field. It is a, let us consider, this is a uniform magnetic field. It is a uniform magnetic field. A bar magnet is placed, a bar magnet. Okay? A bar magnet is placed. It is a bar magnet, so it has two poles, north pole and south pole. So this bar magnet makes an angle theta. This bar magnet makes an angle theta with the uniform magnetic field. With the uniform magnetic field. Since the solenoid is a circular, so what is the magnetic field for the circular area? For the circular. In the previous class, we know that the magnetic field for the circular area, what? We know that this is mu naught I r square n divided by what? 2 into x square plus r square whole to the power 3 by 2. Okay, in the previous class we know this. Here r denote it's the radius. Capital N denote number of turns. I be the current, and mu naught, and here the mu naught. This mu naught is a what? Absolute permittivity in the free space. So we have to find out the magnetic field for the circular area, circular solenoid. Since it is a circular, therefore the area of the circle, circular solenoid, what? This is A is equal to this is pi r square. Okay. Now come to the main points. Look at this too. Starting the point. Let us consider a circular. Let us consider a circular solenoid. Let us consider a circular solenoid, okay, circular solenoid having the current, what? Having the current is what? I. Let P be any point, okay? P be any point from the center O, with a distance, okay? With a distance what? With a distance is, look at the diagram, which is with a distance is R. Okay? With a distance is R. Okay? Now, okay, do this. You can skip your skip something related to the problem. Now, look at this. Let us consider a small segment. Let us consider a small segment having area what? Dx. Having area dx. Number of turns is what? Is n dx. Number of turns is n dx. With a distance what? With a distance x from O. With a distance from O. Assume the radius of the solenoid is what? Is I is equal to A. is R is equal to 8. Let the bar magnet is placed in the where uniform in the let the bar magnet is placed in the where in the uniform magnetic field. Let the bar magnet is placed. Let the bar magnet is placed in the uniform magnetic field. Okay, look at this. Bar magnet is placed. Okay, the bar magnet is placed where in the where uniform magnetic in the uniform magnetic field makes an angle. Look at this diagram. Makes an angle what? Theta. Makes an angle theta. The bar magnet has a two pole, north pole and the south pole. So from this diagram we know this, all of this. We get all of this. Now, okay. Since the solenoid is circular, therefore the magnetic field for a circular coil. Okay. Now look at this. Okay. Look at this. Let us diagram. The magnetic field. The magnetic field. The magnetic field for a circular coil. What? For a circular coil. Since the magnetic field. Since the magnetic field for a circular coil is what? dB is equal to what? This is mu naught I R square into N divided by what? Divided by 2 into x square plus r square whole to the power, this is 3 by 2. In the previous class we do know this. Mu naught I r square n 2 into x square plus r square whole to the power 3 by 2. Here capital N denote the number of turns, I be the current, r be the radius, So we have to find out the magnetic field from where? From this point. From this level, give it some name, this is M. Okay? So we have to find out the magnetic field from where? From M to P. Where it is M to P, then the distance what? Then the distance becomes this is R minus X. Okay? So we have to find out the magnetic field from M to P. So M to P, the distance from M to P is what? This is R minus X. Okay? Now, also one thing, the length of the circular solenoid is twice. The whole length of the circular solenoid is twice. So this is the center point, this is the center. So from here to this is L, and from here to this is L. Then the total length is what? Then the total length is twice. Okay. So from this we can write, yes, dB is equal to what? dB is equal to mu naught remain same. Mu naught. I comes. R be the radius. In this diagram, the radius is what? A. This is A square. And capital N denote the number of turns. So what is the number of turns in that coil? So number of turns for this shape is what? N dx. So we can write this N dx. Okay? By 2 into what? 2 into x square. X square means distance. That distance what? R minus x. R minus x whole square plus R square. R square means is A square. Whole to the power, this is what? 3 by 2. Okay? कितना इजी है देखो. Okay. Now, what? If we add, if we add all the integrated part, all the integrated parts from L to minus L, if we add all the integrated parts from L to minus L, then the total magnetic field, then the total magnetic field means integration. We have to integrate this one. The limit varies from minus L to plus L. Okay, this will become mu naught I A square N dx by what? 2 into this is R minus x whole square plus A square whole to the power, this is 3 by 2. Okay? We have to integrate this one. Now we can, okay. We have to integrate this part. So integration dB means what? Integration dB means this is dB. Also, we got one thing. If R is very greater than A, one thing you look at here. If R is very greater than A, if R is very greater than A, and R is very greater than L, R is very greater than A, and R is very greater than A, then we can write therefore what this is, look at this, therefore we assume R minus this part, R minus x whole square plus A square whole to the power 3 by 2 becomes what? Becomes this R cube. Becomes R cube. Okay? Okay? Becomes R cube. So इसका वैल्यू क्या होगा? This becomes this is R2 हो जाएगा. Therefore, okay? Therefore, the magnetic field B becomes what? This integration minus L to plus L, remaining what? Mu naught I A square N dx by 2 into the value becomes this is R. Okay. After I indicate, we obtain this part. Here limit varies from minus L to plus. Now, what become? Now look at this part. Here the constant part comes out. Also we will here the constant part. Constant part, what is constant part? This is out. This is mu naught I a square n by twice r. These are the constant part. So remaining part minus L to plus L. This is. So the remaining part is this. तो इंटीग्रेशन dx का वैल्यू क्या होगा? इंटीग्रेशन dx का वैल्यू होगा x. So by integrating all of this part, so we get this is what? Mu naught I a square n by twice r cube. dx का वैल्यू होगा x. So become this is L plus L minus L to plus L. Minus L become plus L. So L plus L, we all of you know this equation. Okay. So we will what? Mu naught I a square n into twice L by what? Twice R cube. Okay. By this is twice R cube. Okay. We get the magnetic field. Okay, now we can illustrate this part. एग्जाम में ये सवाल पूछे जाते हैं. This is very important, I think. Okay. Since the magnetic moment for a solenoid, we know that the magnetic field for the solenoid, since here the magnetic field for the solenoid for the solenoid is what? Magnetic field for the solenoid is equal to what? Since not it is in the magnetic field, it is magnetic moment. Since the magnetic moment, okay, magnetic moment. Since the magnetic moment for the solenoid is what? Magnetic moment divided by m. M is equal to what? M is equal to this is N I A. This is M is equal to what? N I A and minus what? Number of turns into current number of turns current into area of the coil, into what? Area of the coil. So here into number of turns, what to it becomes some mistake here. Okay, look at this. that is magnetic moment N into length is twice L into current is I into this is pi r square. Magnetic moment M is equal to what is N into twice L into I into this is pi r square. Pi r square. This is the formula. Okay. So from all of this by calculating, we get that the magnetic field, the magnetic field B, it becomes what? Mu naught by 4 pi, mu naught by 4 pi into twice m into what? Twice m divided by this what? R cube. Mu naught by 4 pi twice m by this R cube. Okay. It is proved by experimentally. For a bar magnet, it is proved by experimentally. Therefore, we know that the nature of the bar magnet, from this experiment we know that the nature of the bar magnet and the solenoid is same. Okay. So this is the required equation. This is the magnetic field for the circular solenoid. Okay. So this is the topic. So if you have any doubt, if you have any question, then if you have any suggestion, then in the comment box you can advise me. If you have any question, then you can also ask me. Okay? Thank you.